Hey everyone, so the next section involves measuring different lengths or distances. It's called indirect measurement. It's section 7.3. Okay, and the definition here, it's the method of using similar triangles and proportions to find an unknown length or distance. Okay, there's not too many notes today, so I'm gonna move this. So that's all the notes we're going to write before we get into our examples. There's two common strategies involving indirect measurement. One is using a mirror. Okay, whenever the problem involves using a mirror, what you want to do is, or what happens is, two similar triangles are constructed that look like this. There's the mirror, and then these two triangles are similar by angle. What ends up happening is you have these two angles which are 90 degrees, and then these two angles are also congruent, and that's because we'll get into it in the example. I'll tell you why then. And the other strategy is shadow lengths. If the problem ever involves shadow lengths, the triangles or the diagram will look like this, similar to this one. Okay, and what ends up happening is, like, let's say the sun is here, it's casting a shadow down onto some figures. It doesn't matter what they are, and what ends up creating is again two similar triangles that are right triangles. So this angle is the same, and then this angle up here is the same as this angle. So again, both of these triangles are similar by angle. These pair and these pair. Okay. Pause that if you need to finish writing that, or if you need to finish copying it. Let me move that. I'm going to flip it over and do the examples. You don't have to get too elaborate with the diagram. If you want, you can just draw in the two triangles, and you'll see what I mean. So again, what we end up having here. See, this person wants to find the height of this flagpole. So what she did, it looks like it's a female, is she walked away from the, well, she put like a mirror down. That's a mirror. And then she backs up until she sees the top of the flagpole on the reflection of the mirror. And what happens is the way light is reflected off a mirror, is this angle is reflected at a similar angle going up. Okay, and then here you see this is a right angle and this is a right angle. So again, what we end up having is the little diagram that I put in the back. You have a big angle, and then you have a smaller triangle, but they're similar. Okay, this length is 4 feet, that's 8 feet. Over here you have 24. And then the height of the flagpole is what you're trying to find. So we have the similar triangles, and now let's throw in the proportions to actually solve this. So the proportions we can use these measurements. The triangle on the left, 4 is the height of the person, and then 8 is how far the person is of the mirror. Height is the height, or h is the height of the flagpole, and then 24 is how far the flagpole is to the mirror. So that's how the proportion would look. Cross multiply 8 times h, multiply 24 times 4, divide by 8, divide by 8, and then you get the height is equal to 12. So I know that would be 12 feet. Okay. Now if you want, just write in the diagram here. Okay. And then your answer. Now sometimes you'll be given the problems with a diagram, and then sometimes you're just given word problems. Okay. You need to determine, is it using triangles or is it using shadows? And you should find it somewhere in the wording of the problem. See, this one is shadow, this one is shadow. If you look over here, this one here is using a mirror, right? This one's using a mirror. Okay, so depending on if is it shadows or mirrors, that's going to tell us how my diagram looks. So this one is for the mirror. On the bottom, I have an example of shadows. So this one just says use similar triangles and shadows to find the height of the lamppost. So again, this person standing here is 5 foot tall, and they cast a shadow that's 10 feet long. The light post, we can't measure it because it's too tall, but I know it casts a shadow of 20 feet long. So what you have is that triangle and that triangle, and they are similar triangles, and because they're similar triangles, we can write a proportion to solve for the missing variable. I'm going to put these numbers on top only because it's a triangle on the left, h and 20, h and 20, and then underneath I'm just going to put 5 and 10. And then again, you should know these two go together because that's the height of the lamppost and the height of the person. So they go together. The 20 and the 10 go together because it's 20 is the length of the shadow and 10 is the length of the shadow. Okay. And then we just finish this off by solving this. Cross multiply, that's 100. Cross multiply, that's 10 times h. Divided by 10, divided by 10. H equals 10. Okay, so the height of that lamppost is 10 feet. And that is what we're working